This lesson is about parallel lines and proofs involving the angles that are formed when you have parallel lines. For this lesson, you're going to want to have printed out the postulates and theorems page that's posted on the right-hand side of the haiku page and have this list with you so that you can reference them. Main things that we're going to be using is we use the reflexive property, substitution property, and most of the properties we'll be using are going to be on these first two pages. These congruent supplements theorem, vertical angles, and then we'll be working with these theorems that involve parallel lines. I'll point them out to you as we come to them, but you want to be real familiar with the theorems and what they say. That way we know when we can use them. So let's get started. First, I want to talk about different types of angles. These angles, corresponding angles, alternate interior angles, and co-interior angles can be formed anytime you have two lines that are intersected by a transversal. So here we have these two lines, and they're intersected by this transversal. The two lines do not need to be parallel. When we know the lines are parallel, there's other things that we'll know because we'll know certain angles are equal in measure. But even if the lines are not parallel, we know we still have corresponding angles, alternate interior angles, and co-interior angles. Corresponding angles, the first group, are angles that are in the same position relative to the two lines in the transversal. So if we have this angle up here, we'll call it angle 1. Let's erase this, make it a little bit easier to see. This angle up here is angle 1. It is above its line and to the left of the transversal. This angle down here is above its line and also to the left of its transversal. I'm going to call it angle 5. So angle 1 and 5 are corresponding angles because they're both above their line and to the left of the transversal. This angle, angle 2 over here, is above its line, but it's to the right of its transversal. It's in the same position as angle 6. So those two angles are corresponding angles, 2 and 6. Angle 3 here is below its line and to the left of the transversal. So we want the angle that's below this line and to the left of this transversal. That's angle 7. So 3 and 7 are corresponding angles. And then 4 and 8 will be corresponding angles because they're both below their line and to the right of the transversal. Alternate interior angles are the next angles that we're going to talk about. I'm going to go ahead and number these angles the same as we did the first group. At any time you want, you can pause this video, draw the picture, and then pick up again and take notes. You'll want to take notes on this just like you would if you were in class. When you see this word interior, we know interior means inside. So let's grab this highlighter and highlight what's inside the two lines. These angles here are what we consider our interior angles. 3, 4, 5, and 6 are interior angles. When you see the word alternate, you know that alternate means switching, and so we want angles, let's switch back to the pen, that are on alternate sides of the transversal. So angle 3 and angle 6, they're on opposite sides of the transversal, but they're both on the interior of the two lines. So they're alternate interior angles. So what would the other set of alternate interior angles be? Well, that would be angle 4 and angle 5. So they're on alternate sides of the transversal, and they're inside the two main lines. Co-interior angles. So we know we're still talking about this inside portion. Let's give them the same numbers, 3, 4, 5, and 6. But they're co-interior. Think about if you're co-captains, you're together, you're doing the captaining together. So co-interior angles are angles that are together. So that would be angle 4 and angle 6 are going to be co-interior, and 3 and 5 are going to be co-interior. All right, let's go ahead and start a proof that involves these. Switch back to the pen. Here we know lines M and N are parallel, so I'm going to label those for you. M and N are parallel. And transversal T intersects lines M and N. And we want to prove angle 1 is equal to angle 2. Angle 1 is this angle here, and angle 2 is this angle here. You would need to be told which those are. And I'm going to throw in another, I'm going to name another angle down here and let that angle help us. The reason I'm choosing this angle here is because I see that it's related to angle 2 because they're vertical angles, and I see that angle 1 and 3 are corresponding angles, so that's going to help me pull this together. If we go back to our list of postulates page, and we look at the parallel lines postulates, we look at this one here. It says if two parallel lines are intersected by a transversal, then corresponding angles are equal in measure. Well, if we come and look, angle 1 and 3 are corresponding angles, and we know lines M and N are parallel, so we know that angle 1 and angle 3 are equal in measure. 2 and 3 are vertical angles, and we know the vertical angle theorem says that vertical angles are equal in measure. Well, if angle 2 is equal to angle 3 and angle 1 is equal to angle 3, then what do we know? Well, we know that 1 and 2 must be equal by substitution. So what we're going to do is write out this proof. We start out with the given. Line M is parallel to line N, and we have the transversal T. So we know that they're both intersected by the same line. That's given. Then we said angle 1 and angle 3 are corresponding angles. And since the lines are parallel, that means they're equal. So we're going to say the measure of angle 1 is equal to the measure of angle 3. It's important that we say measure because that tells us we're talking about a number, and numbers are the only things that can be equal to each other. This is by the theorem we just looked up that says parallel lines. When you have parallel lines, that implies that corresponding angles are equal in measure. Now we also said we know that angle 2 and 3 are equal in measure because they're vertical angles. So we're going to say the measure of angle 2 is equal to the measure of angle 3, and that's the vertical angle theorem. Doing proofs goes a lot faster if you know all the theorems and postulates and know what they say, so be sure you're very familiar with them. Now, since we know that angle 1 is equal to angle 3 and 2 is equal to 3, that must mean that the measure of angle 1 equals the measure of angle 2, and that's substitution. We always want to write out substitution because otherwise it could look like subtraction. So it's substitution, and we might want to say it's of steps 2 and 3. Those are the steps that we put together. I'm going to go ahead and stop this video here, and we've got a couple more proofs that'll be on part 2.